Okay guys, this is the lesson on points, lines, and planes. First I want to talk about some basic terms here. Postulate means a statement that is accepted as true without proof, also called an axiom. As we go along here, there'll be statements that we just accept as saying, okay, they're true, we can't prove them any way they're true, but we know they're true. And there are other statements that we can actually prove using these postulates. And so one of our basic building blocks in geometry is the postulate. Another basic building block is a point. Now, the simple definition of a point is just it is a location in space, and we represent that by a capital letter. Now, a point is always labeled with a capital printed letter. It has no size. One point is not bigger than another, no matter how big you make it with your pencil or whatever. Also, I am very fussy about notation on this because a point is a printed letter. This is not the place for you to exercise your artistic talents of how fancy can you make a printed letter. This is just a printed letter, plain and simple. Next we have a line. Now a line is a straight path that has no thickness and extends forever in both directions. So in this case this would be line AB. We can also call it line L. Now notice again on notation we have our two endpoints, we have our 2 points we have a little mini line above them with the little arrowheads. That tells me I have a line, or we can just call it line and then the lowercase letter. The order of the letters does not matter when you're talking about a line. So line BA is the same as line AB. They're the same thing, they work the same way, doesn't matter at all. Now two words that probably are going to be new to you are collinear and non-collinear. What collinear means is that these are points that lie on the same line. For example, if I have a line that has A, B, and C, then A, B, and C are going to be collinear. Non-collinear means points that do not lie on the same line, and in fact that I cannot draw a straight line through those points. So in my example above, A, B, and D are non-collinear because I can't take one straight line and go through those 3 points. Now since I can always draw a line between any 2 points, kind of almost by definition, 2 points are always collinear. So for example, if I've got these 2 lines intersecting, points G, H, and J are all along one line, so they are collinear. If I look at points F, H, and K, I can't draw one straight line between those 3 points, so those are non-collinear. Now if I look at the points J and K, even though they're not on the same line, I can still draw a line between them because again, I can draw a line between any 2 points, so those 2 points are collinear. Now a line segment is the part of a line and consisting of 2 endpoints and all the points between them. And just like on a line, the order of the letters does not matter on a line segment. You can call this line segment AB or line segment BA. What is important is that you're using capital letters and you're putting a little bar above the letters to show that it's a line segment. The last kind of part of a line we're going to talk about is a ray. Now a ray is part of a line that starts at an endpoint and extends forever in only one direction. And so in this example I have a ray that starts at point A and it goes through point B, so we call this ray AB. And so we put the 2 letters, we draw a little arrow above it, and that tells me that my endpoint is at A and it goes through B. When you're talking about rays, order of the letters does matter. If you have your little arrowhead starting at B and the arrowhead ends at A, that says that you're starting at B and it goes through A, which is not the same thing at all. Now opposite rays, there's kind of a weird little construction here. If you take 2 rays that have a common endpoint and you stretch them, one going off in one direction, one going off in exactly the opposite direction, it forms a line. And so anytime you see a line that has 3 points on it, you can actually also think of that as a pair of opposite rays. The only thing you have to be careful about is, again, remember that when you're doing your notation, the end of your little arrow has to be over the end point of the ray. So in this case, we would call this ray RS and ray RQ. Now you can, do I have that right? Nope, I don't. Sorry. Actually, I have this wrong on my PowerPoint. You can also write RQ as QR if you reverse the direction of the arrow. When I was fixing my PowerPoint, I didn't do that correctly. So pretend that the arrow on QR goes the other direction. All right, plane. Now, plane, besides being a flying thing in the sky, is also a flat surface that has no thickness and extends forever in all directions. So if I've got and the biggest problem with a plane is that it's essentially, we're trying to represent something that's an infinite thing in two dimensions on 2 dimensions. And so the usual convention for that is to draw a parallelogram to represent the plane, and we just accept that it's going off forever in all directions. We just can't see that. And so this parallelogram with the 3 points in it represents a plane. So this plane has 3 points, A, B, and C, and then it also has this little fancy letter in the corner, which means that it is basically that's a way that we denote a plane. Is we can call it a capital letter, but it needs to be something we won't get confused with a point. So we usually use like a cursive letter, or this is the place if you want to exercise your artistic talents, this is the place to do it. So we can call this plane ABC, or we can call this plane R. Now if we're going to use 3 points, they have to be 3 non-collinear points. Because if they're collinear, then we just have a line. We don't have a plane. So just like we had coplanar and non-coplanar, if we had collinear and non-collinear, we have coplanar and non-coplanar. So coplanar points are points that lie in the same plane. So in this instance, points A, B, C, and D are coplanar. Non-coplanar are points that do not lie in the same plane. And essentially what this means is that I cannot draw a plane through them. Not just that I don't represent the plane that I have, is that I cannot make a plane that includes those points. So in this case, points A, B, C, and E are non-coplanar. Now, just like we had 2 points were always collinear, 3 non-collinear points are always coplanar. So if I've got this plane here that has these points on there, I want to come up with 3 different ways you can name the plane below. Well, it turns out that I can call it plane T, or I can pick any 3 letters in any combinations I like, except for the letter S. Okay, because S is a point that is outside the plane, and so I can't use that to name that plane. Finally, I want to talk about, we talked at the beginning about the word postulate, which is something that we're accepting as true without proof. Part of that so we're going to talk about some specific postulates that are some of the building blocks of everything else we're going to be doing. The first one of these is that through any 2 points, there is exactly 1 line. And one of the reasons why we say this is true without proof is that, I mean, you can pretty much, if you put two dots on a piece of paper, there's only 1 line that you can draw that's straight that goes through those 2 points. Anything else is going to be curvy and wander all over the place. But a straight line, there's only 1 way to do that between 2 points. The next one is kind of similar to that, although it's a little bit harder to visualize. Through any 3 non-collinear points, there is exactly 1 plane containing them. It's kind of related again to if you can kind of see it with the line thing, it translates pretty well to the plane. If 2 lines intersect, then they intersect in exactly 1 point. Again, you can test this out for yourself. If you draw 2 lines, 2 straight lines, you can't get one to double back and cross the other line again. It's only going to intersect in 1 point. And then again, related to that, talking about planes, If two planes intersect, then they intersect in exactly one line. So if you think about where your wall and your ceiling intersect, you can kind of see that straight line that forms the intersection point. And that's kind of what we're talking about here. So for examples here, if I have these two planes intersecting, the intersection of planes H and E is going to be a straight line, which is going to be the line, we can either call it RS, we can call it SR, as long as we put the little double arrowhead above it, or we can call it by the lowercase letter n. Now the intersection of M and N, now M and N are lowercase, which means that we're talking about lines again. So the intersection of two lines is a point, and that point in this case is point X. Line K intersects plane E at the point Y. And then R, X, and S are a line, so they are collinear. So what I'd like you to do now is make sure you've got everything filled out as much as you like. Go ahead and glue or tape this into whatever you're going to be using as your notebook in this class, whether it's a spiral, a composition book, or just loose leaf paper is fine, whichever you want to do. While this isn't exactly in Cornell Notes fashion, you can still, especially those of y'all who are an Avid, you can still go through there and write your essential question. You can also go through, make whatever additional notes you need to make. What kind of questions do you want to put as far as what might be good review questions, that sort of thing. And then we will go ahead and talk about this a little bit when we get back to class. All right, bye-bye.